Hey, Transmath class, we are going to start with chapter 3, and first section we're going to look at multiplying, and actually we're going to be doing this throughout the chapter, which is a little easier than adding and subtracting. I think we're going to be multiplying fractions together, but before we do that, we're just going to review some of our multiplication facts. And so if you're not remembering these, you can grab your multiplication table, but you can fill these out with me. So 3 times 7, you should be able to find that to be 21. 4 times 8 is 32. 5 times 6, 2 times 9 is 18. 7 times 7 is 49. 5 times 7 is 35. 8 times 7 is 56. 9 times 9 is 81. 4 times 4 is 16. 6 times 3 is 18. 6 times 9 is 54. 35 there, 64, 12, and 12. All right, so that was just a quick review of just multiplying. So we're going to be doing a lot of multiplying with fractions. Okay, so really what is multiplication? So multiplication is really just repeated addition. So here, like, they give us a model for kind of visualizing what 4 times or 5 times 4 is. And if you have a row of 4 circles and you do that 5 times, well then the total number of circles you have there would represent 5 times 4. So 5 by 4, 5 times 4, we know that that's the same as adding 4 up 5 times, and so that would be 20. Okay. Model 2 is just repeated addition of 4, so if we add 4, add another 4 to 8, another 4, 4, and 4, we end up at 20 if we do that 5 times. 1, 2, 3, 4, and 5, so we end up at 20. Okay. The other thing you can do is called an area model, and that's where you just have the squares in there, and you could count all the squares that are inside of this. 5 units by 4 units, we'd see that there's 20 square units in there. Okay, so a lot of what's going to happen in this first section is you're going to be taking a whole number times a fraction, right? So if we have 3 times 1/2, that just means we're going to have 1/2 3 times. It's like, so we're kind of adding it 3 times, puts us at 3/2. What you're going to notice on these basically is the whole number gets multiplied by the numerator, and the denominator just stays whatever it is. So 3 times 1 is 3, so you just get 3 over 2 for your solution there. Okay. Now here, there are going to be some problems where they say use the number line to write a fraction multiplication problem. So based on what they're showing you right here, it looks like they start at 2 over 4 and they do it again, so it's 4 over 4, 6 over 4. So they've done it how many times? 1, 2, 3 times. So it's 2 over 4 times 3, which means our answer then, 3 times 2 would be 6, so I get 6 over 4. Okay, that's what they're looking for there. So the first fraction that it goes to is right here. It's 2 over 3, and then how many times do we count that? Just twice, so times 2, and where do we end up with our answer? 4 over 3. Okay, so the 2 times this 2 gives us the 4. The denominator stays 3 for that one. Okay, so it says rewrite the whole numbers as fractions. So an idea here is that any whole number can be written as a fraction if you put a 1 in the denominator. So you can always put any whole number over 1. So 5 is the same as 5 over 1. 25 is the same as 25 over 1. 79 is the same as 79 over 1. 100 over 1. 1,599 over 1. Okay, so we can write any whole number as a fraction if we have a denominator of 1. Okay, and so here this is kind of what we were doing in that last example. I guess they're putting the whole number first. It doesn't really matter, but they're saying, okay, we multiplied something twice, so 2 times, and what did we multiply twice? 2/4. Right, so the first one, 2/4, and then we ended up at our answer of 4/4. Okay, so like in this one, how many times? 1, 2, 3. So we've multiplied something 3 times. What was that something? Well, what's the first one here? 2/4. And where did we end up at? 6/4. And so really what we've done is 3 times 2 is 6. And technically, we can, we could think of this as 3 over 1. We'll get to that. Okay, here, how many times did we multiply? 1, 2, so it's 2 times. And what did we multiply by? 2/3. So 2 times 2/3 gives us right here 4/3. Okay, more of the same here. So 1, 2, 3, 4. We multiplied 4 times. What was it that we multiplied? 2/5. And what did we end up at? 8/5. Okay, 4 times 2 is 8, and keep the denominator of 5. All right, here, 1, 2, 3. We multiplied 3 times. And what did we multiply? 3/6. So 3 times 3/6 would be 9/6. Okay, 3 times 3 is 9/6. Okay, so there's a problem-solving activity that's a little bit of a geometry introduction. So it says in this lesson we've learned the differences between points, lines, segments, lines, and rays. And we've also learned how to use letter and symbols for these objects. Okay, so we're going to do a little introduction to that. So a point refers to just a position in space or on a plane. And so we have I just put a dot there. So point A would be like this. A line segment would be just from one starting point to an ending point and your line connecting it. So this would be line segment AB. Okay, so the symbol for that is just AB with a bar over it. A ray has a starting point, but then it keeps going forever on one side. So ray AB, we have 2 dots on there, but then we have an arrow at the end. And then a line extends in both directions forever. So line AB would have an arrow on each end. Okay, so it says for each problem below, first label the point shown on the diagram, then use letters and symbols to answer each question. Okay, so we just have to label each point. We can use whatever letters we want. I'll just go A, B, and C. So what's the name of the line segment? Well, since I went AB, I'm going to call it AB, and line segment has a bar over it. Okay. And we have to name these points. So I'm just going to go down the alphabet. I already did A, B, C, so I will do D, E, F, G, H, just like that. Okay, so what is the name of the line segment? Well, we have a couple line segments. But I guess we'll just do the one that's in here, DE, since those just have endpoints. So we go DE for that one, since there's a segment. The line, there's a few different ways we can name this line. I'll just say FH. We could call it FG or we could call it GH, but I'll just use the ends that are on there. So FH, and then you have to put arrows on the end. Okay, so now we have to keep, so where's that H? So let's go I, J, K, put L in the middle. So what are the names of the line segments? So we've got a bunch of them here. So if I mark these off, so there's one line segment. So I'll call that one I, K, and another one right here, I could call it IJ. Another one right here, I could call it KJ, KJ, and I got another one in here, I can do KL, KL, and here I can do JL, oops, JL, and one more, IL. And so for each one of those where I just do the 2 letters, I put the bar over top, just to say that it's a segment. Okay, and right here, I have to label the letters. Where did I end up at? L. So I'll do M, N, O, and P. So what are the names of the rays? So the rays are the ones that have a starting point and then an arrow on the other end. So I could say NM and NO. Okay, so my rays are here and here, and they extend, remember? Okay, so I've got N, M, N, O. Those would be my rays. Okay, so there was just a little introduction to some geometry there. I wouldn't get too worried about it if you didn't pick all that up, but it's just a little introduction to it.